Welcome to the Confined Space Safety Training Session. In this course, you will learn how to recognize confined spaces, understand the hazards associated with them, and apply the required safety controls. We will review essential topics including hazard identification, atmospheric testing, safe entry requirements, ventilation, communication roles, energy isolation, and emergency procedures. By the end of this training, you should be able to confidently identify confined spaces, understand the risks, and apply safe work practices to protect yourself and others. Let's begin. Definition: a confined space is any area that meets three key conditions. It is large enough for a worker to enter and perform assigned tasks. It has limited or restricted entry or exit points. And it is not designed for continuous human occupancy. Common examples include tanks, silos, pits, tunnels, pipelines, and storage bins. Understanding this definition is the first step in determining whether special precautions are required before entering a workspace.
Hey, Alan! Alan! You okay? Hey, Daryl! Something's wrong with Alan! I'm going down to help him! Call 911! No, wait! Don't go in the tank after him! Richard! Did you hear me? Hang on, Alan. I'll be right there.
Atmospheric hazards. Atmospheric hazards are among the most dangerous risks in confined spaces. Oxygen deficiency below 19.5% can cause rapid asphyxiation. Conversely, oxygen enrichment above 23.5% significantly increases fire and explosion potential. Toxic gases such as hydrogen sulfide or carbon monoxide may accumulate without warning. Flammable gases, including methane or propane, can create explosive environments. Always treat the atmosphere inside a confined space as hazardous until proven otherwise through proper testing. Physical hazards. Physical hazards are also a major concern. Engulfment hazards such as grain, sand, or liquids can quickly trap a person. Restricted movement increases the chances of slips, trips, and falls. Extreme temperatures may lead to heat stress or hypothermia. Noise levels are often amplified inside enclosed areas, increasing the risk of hearing damage. Poor lighting can reduce visibility and contribute to accidents. All these factors must be considered before entry. Mechanical hazards include moving parts of machinery inside the confined space and the risk of unexpected energization. Biological hazards may also be present, including microorganisms found in sewage or decaying organic matter, as well as insects or animals that may enter the space. Other risks include limited access, psychological stress such as claustrophobia, and falling objects from above entry points. Each hazard must be identified and controlled before workers enter the space.
Identification of confined spaces. All confined spaces must be clearly identified by the area supervisor. Warning signs must be posted at every entry point or gate to alert personnel of the hazards within. These signs serve as an important reminder that special procedures, permits, and controls are required before anyone may enter. Risk assessment. Before beginning any work, evaluate whether entry into the confined space can be avoided. If entry is necessary, a formal risk assessment must be completed. This assessment should consider previous contents, temperature and humidity, ingress of hazardous substances, oxygen levels, residues, internal obstacles, and the nature of the work to be performed. Document all findings and implement the necessary control measures to ensure risks are reduced to as low as reasonably practicable. Permit to work. A permit to work, or PTW, is mandatory for all confined space entries. The permit process includes completing the confined space checklist, verifying atmospheric test results, confirming required personal protective equipment, and establishing a rescue plan. Only authorized personnel may issue or approve a confined space permit. Always follow PTW training and procedures carefully. Atmospheric testing. Only a competent air sampler may conduct atmospheric testing. Before entry, the atmosphere must be tested for oxygen levels, flammable gases, hydrogen sulfide, carbon monoxide, and any other toxic gases that may exceed allowable limits. Oxygen must be between 19.5 and 23.5%. Flammable gases must not exceed 10% of the lower explosive limit. Accurate testing is critical to ensuring a safe work environment. Monitoring. If hazardous levels are detected, the source must be identified and eliminated. The space must be ventilated with clean air until safe conditions are confirmed through repeated testing. Entry is prohibited until all hazards are controlled. Continuous atmospheric monitoring must be maintained throughout the job, and readings must be recorded at least every 2 hours. Ventilation overview. Before entering a confined space, toxic or combustible materials must be removed through proper ventilation. Ventilation systems are used to maintain safe air quality and reduce exposure risks. Fans or blowers must be placed to provide effective airflow and prevent areas of stagnant air. Proper ventilation is an essential control measure. Ventilation calculation. Before atmospheric sampling, the space must undergo 7 complete air changes. To calculate the required time, divide the space's volume multiplied by 7 by the ventilation rate. For example, if the volume is 50 cubic meters and the ventilation rate is 2 cubic meters per minute, 7 air changes will take approximately 175 minutes, or around 3 hours. This process ensures the atmosphere is thoroughly refreshed. Exhaust air must always be directed away from the entry point to avoid recirculation. Oxygen must never be used for ventilation due to fire and explosion hazards. Only clean natural or mechanical ventilation is permitted. If the air cannot be made safe, breathing apparatus must be worn to protect workers.
Forced air ventilation. Confined spaces usually have limited entry and exit points, which make it difficult for fresh air to naturally push out and replace the contaminated atmosphere. While atmospheric changeover might eventually occur, it would take a long time. Therefore, to speed up the process of replacing contaminated air with fresh air, forced air ventilation or mechanical ventilation is often used in confined spaces. There are 2 types of forced air ventilation: positive pressure ventilation, and negative pressure ventilation. In case of positive pressure ventilation, air is blown into the confined space, forcing the contaminated air out so that uncontaminated air can move in and replace it. Positive pressure ventilation also does a good job of scouring into hidden nooks and crannies, to make sure no contaminated air is hiding in such places. Negative pressure ventilation is the opposite of positive pressure ventilation. In this case, air is pulled out of the confined space with the aid of a fan, creating negative pressure. As the contaminated air is pulled out, fresh air from the outside will rush in to replace it. It is important to understand that if the contaminated atmosphere is flammable, using negative pressure ventilation may create a danger of fire or explosion. This is because most high-capacity exhaust fans are powered by an internal combustion engine, which greatly increases the chances of ignition as the contaminated air moves through the fan.
energy isolation and low toto. Before entering, all energy sources must be isolated, locked out, and tagged out. This includes electrical, mechanical, hydraulic, and other forms of energy. Tryout procedures must be performed to verify the isolation is effective. Follow low toto training to ensure all isolation steps are correctly applied. Communication. Reliable communication between entrants and the attendant is essential. A pre-entry briefing must be conducted to ensure everyone understands the hazards and procedures. Communication may involve voice contact, radios, or approved hand signals. In hazardous atmospheres, communication devices must be explosion-proof. Communication must remain uninterrupted throughout the entire job. Attendant role. A trained and competent attendant must remain outside the confined space at all times. The attendant must understand all hazards and recognize symptoms of exposure. Continuous communication with the entrants is required. The attendant plays a critical role in ensuring safe operations. Attendant responsibilities. The attendant must maintain the entry log sheet and ensure all documentation is complete. He or she must prevent unauthorized access, apply area isolation, install barricades, and post signage. The attendant must order immediate evacuation if hazardous conditions arise or if entrants show signs of distress. Emergency communication must always be available. If the attendant must leave for any reason, all entrants must evacuate immediately. Additional safety rules. Only trained and authorized personnel may enter a confined space. A valid permit is required at all times. Workers must wear the required personal protective equipment. Entrants must report to the attendant before entering or exiting. Working alone is not allowed. Any unsafe conditions or symptoms must be reported immediately. Ignition sources and gas cylinders are prohibited unless specifically authorized. Electrical and equipment safety. Adequate lighting must be provided based on the task. In flammable atmospheres, non-sparking tools and explosion-protected equipment must be used. In metal tanks, extra low-voltage tools and residual current devices should be used to prevent electrical shock. All equipment must be properly grounded. Smoking is strictly prohibited. Emergency. Emergency situations in confined spaces are extremely dangerous and require a well-planned, well-practiced response. Statistics show that more than 60% of confined space fatalities involve would-be rescuers who entered without proper equipment, training, or authorization. This highlights a critical rule: no one should attempt a rescue unless they are fully trained, properly equipped, and authorized under the site's emergency response plan. During any confined space operation, the rescue plan must be prepared before work begins and must be clearly communicated to all personnel involved. This includes entrants, attendants, supervisors, rescue teams, and control room staff. Everyone must understand how an emergency will be detected, how evacuation will be initiated, and how communication will be maintained throughout the incident. A key component of rescue readiness is the use of proper retrieval equipment. Entrants should wear a full-body harness fitted with a lifeline that extends to a secure anchorage point outside the confined space. This allows rescuers to extract a worker without entering the hazardous environment. The only exception is when a documented risk assessment determines that a lifeline creates additional hazards, such as entanglement or contact with rotating equipment. In every case, the decision must be justified and recorded. Emergency communication devices must be available, functional, and tested prior to entry. This may include intrinsically safe radios, hardwired communication systems, or approved signaling methods. The attendant must remain alert to signs of distress, abnormal behavior, communication loss, alarm activation, or changing atmospheric readings. At the first indication of danger, the attendant must immediately order evacuation and contact the rescue team without delay. The rescue team must be professionally trained in confined space rescue techniques, including atmospheric monitoring, use of breathing apparatus, patient stabilization, and safe extraction procedures. They must also be familiar with the specific layout, hazards, and access points of the confined space being entered. Rescue drills should be conducted regularly to ensure that all personnel remain competent and confident in their roles. Under no circumstances should untrained workers attempt spontaneous entry, even with good intentions. Entering a hazardous confined space without proper equipment exposes additional people to the same danger and significantly increases the likelihood of multiple fatalities. In all cases, The primary objective is to ensure the safety of all personnel by acting quickly, following established procedures, and relying only on trained and authorized responders. Emergency preparedness is not optional, it is a critical part of confined space safety and must be taken seriously on every job.
Rescue from a confined space. In a confined space setting, there are three types of possible rescues: self-rescue, non-entry rescue, entry rescue. Self-rescue is performed by authorized entrants themselves when they spot a hazard and are able to escape from the situation without aid. Non-entry rescue is performed from outside the confined space by support personnel. When the rescue procedures provide for non-entry rescue, each entrant must wear a chest or full body harness, with a retrieval line attached in the center of the back, or another point which positions the entrant so that he or she is small enough to be pulled out of the space. The other end of the retrieval line must be attached to a mechanical device or a fixed point outside the permit space. A mechanical device must be available to retrieve someone from vertical type permit spaces more than 5 feet deep. Entry rescue. Under certain situations, non-entry rescue might not be feasible. If so, the only way to rescue the entrant is for others to enter the permit space. For entry rescue, the employer may plan to use an on-site rescue team or an off-site team, such as a local fire department or other rescue service. Whenever entry rescue takes place, an attendant must be stationed outside the permit space so that additional help can be summoned if needed. If the original attendant is to enter the space as part of the rescue team, a new attendant must be in position before the first attendant enters the space. However, it is preferable if the entrant can be rescued without others entering the space to avoid having additional personnel being exposed to the hazard that caused the injury or illness.
Safety precautions for confined space work. Working in confined spaces presents serious hazards, so proper safety measures must always be followed. Conduct a risk assessment. Identify hazards such as toxic gases, oxygen deficiency, flammable substances, and engulfment risks before entering. Obtain a permit to work. Ensure a proper authorization process before starting work. Ensure proper ventilation. Use mechanical ventilation or fans to eliminate hazardous gases and maintain a safe oxygen level inside the space. Test the atmosphere. Continuously monitor oxygen levels, toxic gases, and flammable vapors using a gas detector before and during entry. Use personal protective equipment where necessary. PPEs based on the risk assessment. Establish an emergency rescue plan. Have a trained rescue team and emergency procedures in place. Use proper entry and exit procedures. Ensure safe access points, ladders, and fall protection systems to prevent entrapment or falls. Implement continuous communication. Maintain constant communication between workers inside and the standby personnel outside using radios, hand signals, or other reliable methods. Assign a trained standby person. A trained attendant should be present outside the confined space to monitor and respond to any emergencies. Control energy sources. Follow lockout-tagout procedures to isolate energy sources such as electrical, mechanical, or fluid systems to prevent accidental activation. Following these safety tips minimizes risks and ensures a safe working environment in confined spaces.